Hello students, welcome back to my channel. Today I come with the next video in continuation with the other videos for Neet to 2022. So without wasting time, let us start discussing. The first question you can see here, question number 13. A spherical ball is dropped in a long column of a highly viscous liquid. The curve in the graph shown which represents the speed of the ball v as a function of time t. Now students, you see, suppose this is a spherical ball and it is dropped in a viscous medium. The medium is viscous. Okay, and as you know that even though this force, downward force, which is equal to weight, remains constant, but the upward force, one of the upward force will be force of upthrust, which will be constant, but the viscous force, which will be opposite to the direction of velocity, is given by 6 pi eta rv, where v is the speed. So initially speed will be less. So automatically what will happen? The opposing force, namely these two forces, will probably be lesser than mg. So it will start moving downwards. But during the course of motion, what happens? It goes on picking up velocity. It picks up velocity. Speed increases. So as speed increases, viscous force increases. A stage comes when the viscous force together with the force of upthrust is just able to balance the downward force, that is weight. In that case, it comes to a state of equilibrium, and we say that terminal velocity has been attained by it. So certainly velocity keeps on decreasing with time. Okay. Velocity, see, initial velocity is 0, students. The velocity increases, and finally it attains a constant value. That is the terminal velocity. This will be the terminal velocity, and it cannot increase beyond this because there is no net force after that. So curve B is the correct answer. So here curve B means fourth option. Then moving on to the next question, question number 14. If a soap bubble expands, the pressure inside the bubble. Now as we all know that the pressure inside the bubble is given by outside pressure plus 4T bar. Since it's a bubble, you have to use 4T bar. So if I write inside pressure as PIN and outside pressure is nothing but atmospheric pressure, of course. For now, I'll take it as PO or P out. Then we have P inward inside pressure is equal to outside pressure plus 4T by R, where R is the radius. So here what is happening as per question, the bubble is expanding. So expanding means R is increasing. So if increases, then this factor will decrease because R is in the denominator. As the denominator increases, students, a fraction reduces. So automatically P inside will reduce. I am showing it with a downward arrow. Downward arrow means decreases. Okay. Right. Then moving on to the next question, question number 15. An ideal gas undergoes 4 different processes from the same initial state. This is the initial state as shown in the figure. So these are the different processes. Those processes are adiabatic, isothermal, isobaric and isochoric. The curve which represents the adiabatic process. Now students, you see one by one we can mark all of them, of course. So here you can see process 1 is basically, here you can see that the pressure decreases from this value to this value, but volume remains constant. So such a process is known as isochoric. Isochoric process is a process in which volume remains constant. Then you have this 2. We'll talk of process 2 and 3 later, but before that let us talk of process 4. As you can see in process 4, pressure remains same, only the volume increases. So pressure is same as isobaric process. Isobaric process is a process in which pressure is same. Now out of curve 2 and 3, one of them should represent isothermal process and the other should represent adiabatic process. And students, as you know that adiabatic curves are more steeper than isothermal curves. Do you remember? So that means curve 3 is less steeper, so it should correspond to isothermal. Okay, and this second process should correspond to adiabatic. because it is slightly steeper. So the second process, fourth option is the correct answer. Moving on to the next question. If the initial tension on a stretched string is doubled, then the ratio of the initial and final speeds of a transverse wave along the string. So we have a simple formula for the transverse wave along the string. See this? Okay. Now, if T is the tension in the string and mu is the mass per unit length, that is also known as the linear mass density, mass per unit length, then you know the wave speed, transverse wave speed is given by under root T by mu. Is it? Now, if the initial tension of a stretched string is doubled, so here the string remains same. So string remains same means mu is constant. In that case, we can write V is proportional to root T. Okay. So V, the ratio of initial to final speed. So V1 by V2 from this equation will be under root T1 by T2. As clearly it is given that the initial tension of a string is doubled. That means T2 is, sorry, T2 is 2 times of T1. That's what is given. So this will be 1 is to root 2. Okay, T1 gets cancelled. So 1 is to root 2 means first option is the correct option. Moving on to the next question. Given below are two statements. One is labeled as assertion A and the other is labeled as assertion reason R. Sorry. Now the stretching of a spring is determined by shear modulus of the material. This is true because when you stretch a spring, okay, when you stretch a spring, you can see that the spring gets twisted or it gets unwinded, probably unwinded when you stretch a spring. So whenever there is a twisting or unwinding, you see this kind of a thing, then shear modulus comes into action. So whenever there is a tangential stress means when the restoring forces act parallel to the surface, then shear stresses are induced in it. So we can say that the stretching of a spring is determined by shear modulus. This is true. Now, the reason a coil spring of copper has more tensile strength than a steel spring of same dimensions. Of course, reason is not at all appropriate. Moreover, this statement is incorrect because if you look into any standard handbook of physics, students, you will find that the tensile strength of copper is lesser than that of steel. Steel is more harder than copper. Here, by tensile strength, we mean the stress corresponding to which a copper wire will break. Tensile strength, that is known as tensile strength. The maximum, what you call stress, which a copper wire can bear, that is known as tensile strength of copper. Similarly, same thing for steel. So this is wrong. This statement is wrong. So we have correct option will be A is true and the reason is wrong. So this is first option is the correct option. Then moving on to the next question. The volume occupied by the molecules contained in 4.5 kg water at STP if the molecular forces vanish away is. Now, when does the molecular forces vanish away? Now, ideally speaking, we all know that in an ideal gas, there is no intermolecular forces of attraction or repulsion. So, ideally speaking, it should be an ideal gas. But even though it may not be possible to convert water into ideal gas, but at least it is possible to convert water into an ordinary gas. That means if water is in the gaseous state, that is vaporous state, then certainly being a gas, we can assume that intermolecular forces have vanished. So we have to assume here water vapor to be as an ideal gas. So taking water vapor as an ideal gas, so here what is it? This much mass of water. Now this is based on simple mole concept, student. We all know that 22, sorry, 1 mole of any ideal gas, 1 mole of any ideal gas occupies how much volume? 22.4 liters. 22.4 liters to be converted into meter cube because the options are in meter cube, you can see. Okay. Now, accordingly, if we can calculate the number of moles, assuming that the water has been converted into gaseous state, that is vaporous state, then we can multiply by the number of moles with this volume, because at STP it is there. So the required volume is number of moles into volume occupied by each mole at STP, that is this 22.4 or 224 into 10 power minus 4. Now, number of moles can be calculated as mass upon molecular mass. So, mass is how much? 4500 gram. I have converted kg into gram. So, kilo stands for 10 power minus 3. So, the decimal has been shifted to 3 places to the right. Whereas for water, molecular mass is 18 grams. So, this will be the total number of moles of water present in this much kilogram of water into this 22.4 into 10 power minus 3. Anything is okay, not a problem here. Then let us go on cancelling this. Okay. Now I'll do one thing. I can cancel this with 3. 3 6 3 15 and 100. Okay. Then again 3 2 3 5 and this can be cancelled as 11.2. Now I can write this as half into 1000. 500 I have written as half into 1000 into 11.2 into 10 power minus 3. So 10 power plus 3 and 10 power minus 3 gets cancelled. Half of 11 by 11.2. Half of 11.2 is 5.6. So second option is the correct option. 5.6 meter cube. Then moving on to the next question. Two simple pendulums of lengths this much and this much, these two lengths are given, are vibrating in the same phase. At some instant, the two are at their mean position in the same phase. The minimum number of vibrations of the shorter pendulum, after which two are again in phase at the mean positions. Now, student, you have to understand this. Let us assume that they start from the mean position. It's not necessary that they have to start from the mean position, but just for the sake of simplicity, sorry, we are assuming that they start from mean position. Now both of them were at mean position at t equal to 0. They start vibrating. The moment they start vibrating, their phase difference occurs between them, because their time periods are different. Now, the one, see, time period is directly proportional to square root of length for any simple pendulum. So more length will have more time period. So this will be slow, because time period is more means this will be slow. This will be vibrating slowly. Whereas the one with less length will have less time period. So it will quickly, it will keep oscillating. So the moment they are again in phase, that means this shorter one would have completed one oscillation more than the longer one. So that will be the minimum time in which it will happen. I mean the minimum time in which they'll again be in phase. So try to understand, students, very very clearly. They start in the same phase from the mean position. Now, by the time they are again in the same position, they are again in the same phase, the minimum time, the shorter one would have executed one oscillation more than the longer one. In other words, the if the time period of shorter one is ns, then number of oscillations in shorter one will be one more. Okay, will be number of oscillations in shorter one will be one more than number of oscillations in longer one. Clear? So that means if I take the longer number of oscillations in longer one as n, then ns will be n plus 1. So I can write. So total time elapsed will be n number of terms in shorter multiplied by time period of the shorter one, whereas from the point of view of longer one it is only n times of longer one. Now this period of oscillation can be replaced by square root of length. So we have n plus 1 into root ls is equal to n into root l longer. So you have n plus 1 into root of shorter one is 100 centimeter long, whereas longer one is 121 centimeter long. So we have n plus 1 by n is equal to square root of 121 is 11 and square root of 100 is 10. So I can straight away write this as 11 by 10, which can be written as 10 plus 1 by 10. So very clearly you can see n is 10. So n is 10, that is number of oscillations in the longer one. Longer one is 10. What they are asking? They are asking the minimum number of vibrations in the shorter pendulum. In the shorter pendulum, it is n plus 1. So 10 plus 1 will be 11. So third option is the correct option. Okay, that's all in this channel, in this video, students. Thank you so much.